Hello everybody, welcome to Pencil College. Okay, so after learning some applications, we will now go back to learning how to differentiate other kinds of function, not polynomials, but trigonometry. And in the later chapters, we also learn how to differentiate exponential and logarithmic functions. Okay, so the lesson objective is actually learning how to differentiate sine, cosine, and tangent. Okay, so the derivative of the trigonometric functions are as such. So if you were to differentiate sine x, you actually get cosine x. Differentiate cosine x, you get sine x. Differentiate tangent x to get secant square x. Okay, so it's very clear cut. You have to remember this. Okay, and take note that for cosine, after you differentiate cosine, you get negative sine. Okay. Okay, so let's try a few examples. Example 1, A. So we have to differentiate y is equals to cosine 2x. Okay, so differentiate y equals to cosine 2x. We will just have, since the cosine, after differentiating, I will get a negative sign. So dy dx is equals to negative sine 2x. Okay, however, because this thing is not x, so we can treat it like as if it's a big X, and then we have chain rule, so we have to differentiate this big X as well to get 2. Okay, so it's negative 2 sine 2x. Okay, so please recall chain rule. Chain rule states that to find dy dx, it's actually the same as doing dy dt over dt times dt dx. Okay, so this is what, so we are doing chain rule once again. We're treating this as another variable, and then we differentiate it like as if it is x, and then after that we differentiate this variable inside. Okay, so the second example is y is equals to 5 cosine 2x plus 3. So we differentiate this, b. We differentiate this, we will get 5. We will keep the 5 because you don't differentiate this multiple of a cosine. So you keep this, and then you just differentiate cosine 2x, and then differentiating the 3 will actually just give me 0. So effectively I'm only doing this. So 5 d dx of cosine 2x we have over here is negative 2 sine 2x. Okay, so then we have negative 10 sine 2x. Okay, that's all. Okay, so in this second example, we need to differentiate y is equals to tangent 2x times sine 3x. So recall, to do this, we actually need to make use of two rules. One is chain rule, which we have said above. The other one is product rule. So remember, we said product rule. So if you d dx of u and v, where both u and v are functions of x, then what you will get is u dv dx plus v du dx. Okay, so this is multiplied and this is multiplied. Okay, yeah, so finding dy dx over here would just say that we keep the tangent. Okay, keep the tangent to x, then we differentiate the sine 3x, which will then give us negative cosine 3x times 3, because I have to differentiate the variable inside the cosine as well. So times 3. Okay, and then we have to plus, keeping the sine 3x, differentiating the tangent 2x. So differentiating tangent 2x will give us secant square 2x times 2, because after differentiating 2x I get 2. Okay, so what I will have here is so let me rearrange the terms. So I will have 2 secant square 2x sine 3x minus these terms over here, 3 tangent 2x times cosine 3x. Okay, so that's all. So in summary, for a function y is equals to sine x, you differentiate, you get cosine. You differentiate cosine, you get negative sine. Differentiate tangent, you get secant square. Okay, and don't forget the variables inside here is all x, so there's no chain rule involved. Okay, but cases are you don't get such a nice variable inside like x, so you probably get like 3x plus 4 or something like that. You just have to use chain rule. Okay, so treat the whole thing as one first, then do the differentiation, and after that differentiate what is inside this parenthesis or this bracket. Okay, here are some practice questions that you can try out on your own. Okay, do try them. Okay, this is the end of the video. I hope you enjoyed the video. For more videos, please visit www.pencilcollege.com. Thank you.